Tuberculosis, or TB as it's more commonly known, is a contagious disease predominantly attacking the lungs, brought on by the bacterium Mycobacterium tuberculosis. As of 2022, TB stood as the second highest infectious slayer globally, second only to COVID-19, claiming approximately 1.3 million lives, inclusive of those living with HIV. Thus, TB has emerged as a major concern for public health across the globe. TB manifests in two primary forms: the active TB disease and a latent TB infection, LTBI. Active TB disease exhibits noticeable symptoms and can be passed from individual to individual. Conversely, LTBI is a state where the bacteria lie dormant within the body, presenting no symptoms and refraining from contagious behavior. However, there's always a possibility of LTBI evolving into active TB disease in the future, causing potential reinfection. This is why detection and treatment of both LTBI and active TB disease are crucial for managing TB effectively. This is especially true in areas with low TB prevalence, where the majority of non-imported TB disease usually stems from an evolution of LTBI. There are currently two available tests on the market that can detect LTBI: the tuberculin skin test, TST, and the interferon gamma release assay, IGRA. Since both tests measure the human immune response to TB, they can detect LTBI, whereas the other tests cannot detect LTBI. But neither of them can be used as the gold standard for diagnosing LTBI, and doctors will need to carry out other clinical assessments in order to make a determination. Neither of them can distinguish whether a patient is infected with active TB disease or LTBI. The TST operates through the intradermal injection of a purified protein derivative, PPD, encompassing components of the Mycobacterium tuberculosis bacterium. If an individual has been exposed to TB bacteria, their immune system will respond to the PPD, resulting in a raised, firm area of skin at the injection site. However, the BCG vaccination can cause an immune response to the PPD similar to that caused by natural infection with TB bacteria, leading to a positive TST result even in the absence of TB infection. To overcome this limitation, IGRA were developed. There are two main IGRA-based tests on the U.S. market: Qiagen's QuantiFERON and Oxford Immunotech's T-Spot-TB. They are very similar. So in the instance of QuantiFERON, the physician first collects the patient's whole blood in two tubes with the TB antigens ESAT6 and CFP10 and a set of short peptides at the top of the tubes. The doctor shakes the tubes 10 times and incubates the tubes at 37 degrees Celsius. If the patient has had a previous TB infection, his body will contain CD4 plus and CD8 plus memory T cells. When ESAT6 and CFP10 activate the CD4 plus T cells and the short peptide activates the CD8 plus T cells, the T cells release IFN gong, which is detected as an indicator of TB infection. So how does IGRA manage to avert the false positives that can occur in BCG vaccinators? The key lies in the two proteins, ESAT6 and CFP10. The BCG vaccine strain, an attenuated M. bovis isolate, has lost several genomic regions crucial for granuloma formation and persistent infection. One of the lost regions, RD1, carries the genes for the ESX1 secretion system and two secreted effector proteins, ESAT6 and CFP10. IGRA uses these two proteins to stimulate T cells, thereby instigating a potent cellular immune response while preventing false positives in BCG vaccinators. Lastly, the process moves to detecting IFN gong. This can be achieved through various methods, but the most commonly used is the ELISA method. The tubes are centrifuged. The plasma from each tube is transferred into a 96-well plate, which absorbs IFN gong and then incubated. Finally, enzyme-linked antibodies and substrates that can bond with IFN gong are added, inciting a color change. The amount of IFN gong is inferred through the relationship between optical density and concentration. Next video, we will explain the basis of TST and try to discuss which one will be the mainstream test in the near future. Thank you for watching, and if you want to learn more about TB-related knowledge, don't forget to subscribe to our channel.